Okay, so I'm going to go over how to add geoposition information to images taken with a camera that doesn't have a GPS receiver in it. And the way that I came about doing this is that I bought a camera as a sort of a second or third camera that I wanted to use for travel. It's a Nikon D5300, and it's a real small, lightweight camera. Really nice camera. It's a 24 megapixel camera without an anti-aliasing filter. Takes phenomenal images, real small footprint, real lightweight. And the reason I went with the 5300 is because that camera actually does have a GPS receiver in it. But what I've found that my usage, the way that I take photos is that I turn the camera on, I wait for the satellite acquisition, which could take several minutes, then I start taking images, and those first few images, they have position information in it. They're geotagged. But then what I found I was doing was I'm in the habit of turning the camera off, and then I'll move to a different place. I'll turn the camera back on and I'll take some more images, and then I'll turn the camera off. Well, that second and third and fourth time that I turn it on, I don't wait for the satellite acquisition because it takes a while. So what happens is the camera gets satellite acquisition, I turn it off, I go to a different place to take different vantage point or a different position, and then I turn the camera back on, but now I take my photos and then turn the camera off before it's gained satellite acquisition. And so those subsequent images, they don't have any position information in them. So what I figured I would do, and then I also noticed that when the GPS receiver is on the D5300, it soaks up a lot of battery power. And so my battery life is not as great as it would be if I had the GPS off. So what I do now is I turn off Wi-Fi and I turn off the GPS receiver in that camera whenever I use that camera. And instead, what I do is I use a handheld little GPS unit. It's something that I already had. You can see it in this little preview, but I'm going to zoom in and you'll get a better view of the face of that in a second. And so what I've done is I've come up with a way to use track information that is recorded and then saved in a GPX file that I get from the handheld GPS unit. And there's a way to take the GPS track information and to geotag images with that information. And so that's what I'm going to go over right now. And so I'm going to open up this directory in ACDC Photo Studio. That's the asset management software that I've been using for many, many years. And I love it. And I'm actually now using it for doing editing and develop of raw images, but that's a whole different topic. So what this amounts to is the image here is, this is an image of the GPS handheld GPS unit, and you can see over here in the bottom right there is no GPS information, so there's no geotag information in these images. And I would select any of these images and you'll see that there's no position information in it. And so in order for this whole thing to work, as earlier I said, we're going to take track information that we get from the handheld unit. And here's a close-up view of the face of the eTrex 30. That's my handheld little Garmin eTrex 30 is my handheld GPS unit. And the trick to this, the crux of this whole thing, is to make sure that the satellite time is displayed all the way out to the second. And that's important because what we're going to do is we're going to use the timestamp of when the image is taken and compare that to the actual real timestamp, and we're going to use the GPS time as being the absolute and being the accurate time, because that's coming down from the satellites. And that's actually how GPS works. It uses time signals from multiple satellites and then looks at the time delay of when the receiver, in this case this little handheld, gets these signals, and then it triangulates and figures out, well, what is my position on the Earth. And so what we do is we use some software called GeoSetter. It's free software. I'm going to go down to the browser. This is the website for it. Here's a link. You could easily go there. It's free software, great great utility, fantastic. And so that's what I'm going to be using, GeoSetter, and my images. And this actually works for RAW images, it works for TIFF images, it works for JPEG images. In this particular case, I have a collection of RAW images. You can see in ACDC, you can see that these are actually RAW images. These came from a Nikon D500 and shooting in RAW, and that's why they have the NEF extension. So, and none of them, as I said earlier, none of them have right now yet have GPS information in them. So I've set up ACDC to open images in external editors, and one of the external editors I've configured ACDC is the GeoSetter, and so it's just a convenient way to open up GeoSetter with this directory selected, and in that particular case, the reference image. I'm going to call this the reference image. So this process, you're required to take one image of the face of your GPS so that you can see the timestamp. And so we can see the timestamp of that, and then in that directory there was this track GPX file that I got, that I connected my USB connector to this handheld, and I downloaded it to my computer, and I put the GPX track file, and GPX stands for GPS Exchange Format. It's an XML document, so it's a plain text document that contains the geoposition information. This is what it looks like. This is this file, and so it has a timestamp. I'm going to get into a little bit about why I had that highlighted, because there's a little correction that I made here in this particular case. But really what each data point does is, this is a single data point in the track, and it has latitude, longitude, elevation. This is in feet because I had my GPS units set to the units of feet, and then a timestamp. And this timestamp is in Z, which is Zulu, which is UTC, which is Coordinated Universal Time. And that, coupled with the time zone that your GPS unit is set in, determines the local time that you'll see on the front of this. So, like, let's go back to the zoomed in image of this. And so you'll notice in this particular case, well, it looks like it's 11:15 actually in the morning, but this says PM. Well, that's because the GPS unit, the last time I had actually used this, I was in Bangkok, Thailand. And Bangkok, Thailand is UTC plus 7 hours. I'm actually in Chicago, so I actually took this photograph, and this whole exercise was done just west of Chicago, where I live. And Chicago's in UTC minus 5 hours. And so the difference between Chicago and Bangkok is 12 hours. And so because the GPS unit was set on the Bangkok time zone, the satellite signals that this handheld were receiving were converted to the Bangkok time zone. And that's why it says 11:15 and 49 seconds PM, when in reality it's really AM. So what I did was I went into the GPX file, and I adjusted the time. And this is something that you wouldn't have to do. If I had set up my GPS handheld unit correctly from the beginning, I wouldn't have to go in here and screw with this. But the reason that I'm doing this is to explain why there's a discrepancy between the time that's showing up here and the actual time that the images were taken. Okay, so in GeoSetter, back to GeoSetter, this little blue thing is coming from this track, because this little click bar says show the track data on a map. And so I have terrain set. You can set, I have the Google terrain map. That's what we're using for the background. And so what we do here is we use this, what I call the reference image. So I'm going to select it, and then click this little thing, which is Synchronize. Actually, either that, or we can go to Edit, Synchronize with GPS data files. So let's do that. I'm going to click this, and what this is doing now is it's actually giving me some options for setting the time difference between the data that's found in this GPX file and the XF timestamp that's found on the image itself. And so what I do in this case is, because I have the reference image selected, I adjust by image content. Okay, so what this will do is it'll bring up an image of the reference image, and what we do is we look at this timestamp and we say, this is the timestamp of when the image was taken. So what I did before I started taking this series of images is I went into my camera's menu system, and I set the camera clock, the camera time, to as close, the most accurate as I can. So what I did was essentially I got the world clock. I used the world clock website, and I set my camera's time to as close as I could to the actual real time. And so as we see, the time that's coming down from the satellites and the time that's set on my camera, because this one down here is from the XF information that comes from the image file recorded by my camera. There is no time difference. Remember, I have already explained why there's a PM AM difference. But so what we're going to do is say, set this to be whatever this time is. Well, this time is 11:15 and 49 seconds AM. Remember, AM PM. So I'm going to say OK, and what that would do is change the times down here. In fact, let me make a change of 1 second. I'll make it 1 second earlier, and then we'll see that this gets adjusted. But in this particular case, my camera's time was set spot on, so I'm going to reset that to 0, and then we'll just say OK, and I'm going to leave everything else as is. We're going to say OK. Now this little window, this confirmation window, is saying that GPS data was found for all one image. Well, there's only one selected image, and it's saying, do you want to geotag this with information that's coming out of this GPX file? And we're going to say yes. Okay, and so now this little thumbnail has changed, and we can see this little purple GPS information, and then the map changes, and now we have a little push pin in the map. And so what I'm going to do is I'm going to apply the same change to all of the images. So now I've selected all of the rest of the images, and I'm going to click this again. This is the same as doing edit, synchronize. It's just a shortcut. This is a shortcut for opening up the same options window. And everything is already correct because we already set the position information there. So I'm going to hit OK, and now it's going to say it found GPS information for 11 images. Well, actually, let me say no right here. Let's cancel this. And one other thing I wanted to explain in here is that what we're doing here is we're interpolating. And so what happens is we take an image with the camera, and the camera sets the time that the image was taken, and it puts it in its XF information. And then the GPS unit, which is completely separate from the camera, is recording track information. And when it puts down information is dependent on the settings in your handheld GPS unit. I have mine set to automatically figure it out. So if I'm driving in the car and I'm going fast, it'll take less, it'll put down less track information because or actually more, because my position is changing fast. And so it's laying down a lot of information because I'm moving and my position is changing a lot. If I'm walking or if I'm strolling really slowly, then my GPS unit won't need to put down track information as often because I didn't cover as much ground in a shorter amount of time. So, but those are things that are settings in the handheld GPS unit itself, and we're not going to worry too much about that. But what we are going to do is interpolate, which means that if a track, let's say I were walking really slowly, so the track information has information from 1 second. Then I stand there for a few seconds and I take an image, and then I start moving again. Then my GPS unit is going to take another track several seconds later. And so there's the time that the image is taken and the times that track information are recorded in the GPX file are not going to be exact. Like if I were to click assign exactly to the found position, then none of these would be they would never find any GPS information. So what we're doing is we're doing a linear interpolation between, well, we're not, the GeoSetter that's what it's doing, and that's what this means, interpolate, regarding the shoot time with position times that are found. So I'm going to say okay there, and then it's saying it's found GPS data, so it was able to do that linear interpolation for all 11 images. And if we look here, we had a selected 11 images, so that's good. It's going to find position information for all of them. So I'm going to say yes, and now we see that all of the selected images now have this magenta position information. And if we look at the map over here, it's put these little push pins superimposed on the map. And so now I'm just going to click in an empty space here to deselect. And so you can see that these little thumbnails now in the upper left corner have these little pin icons associated with them. And that's saying that, hey, we found position information for these images. And so what I did was I started my track on this road partly on my journey, and really all I was doing was going to take pretty much random images. Just wanted to see that they get geocoded correctly, not geocoded, but geopositioned, geotagged. And so one of the earlier images I took, and I'm just zooming in here, was at the corner of Dauberman. I was driving and I got to the corner of Dauberman Road and Kessingler Road. And so I'm going to click on this, and that'll select this image in this preview in the bottom here. And you can see I took a picture of the street sign there. And I'm on Dauberman Road, and I'm going to make a left turn onto Kesslinger. And you can see that the street sign that's at that corner is correct. I mean, so this image anyway looks like its position information was tagged correctly. So then the next image I took was again at an intersection. This time it's on Meredith Road and the intersection of Illinois Route 38. And so again, here's the preview in the bottom left here. And as you can see from this image, and it's an uninteresting image, but it's giving us all the information that we need. I'm on Meredith Road. The cross street here is Illinois 38. So that looks like it has geotagged correctly. And so then I drove for quite a long time. I don't know why that's selected. We're going to ignore that. And so then I went to this road here, which was German Church Road. And I went off on the side of the road, and actually this GPS unit is so accurate that we could actually see, if we really zoom in, we could see what side of the road I was on. I was on the right side of the road when I took this image. And I'm going to zoom out. Right here, there is the Byron nuclear power plant. That's right on this road. This road goes right next to a power plant, a nuclear power plant. And so I shot this image. I'm going to click on this now, and we're going to look at the preview. And then, as you can see in the preview, the cooling towers for the nuclear power plant are up and to the left. And so you can see that this map is situated with north at the top. And so I shot this image shooting north, almost due north. Well, it looks like it's exactly due north. And as you can see, the cooling towers are in front of me and to the left. And this image was shot in this direction, so in front of me and to the left are the power plant cooling towers. And so then I went up to the end of the road, and I turned around and I took a shot going in the southern direction. And so in this image, if this is tagged correctly, then we should see the northern side of the north cooling tower, and it'll be in front of me and to the right. And so here's this image, and it's in front of me and to the right. And this is the northern face of the northernmost cooling tower. So that looks good. It looks like these were positioned correctly. They were geotagged correctly. So then what I did was I drove back down this road, and you can see, because like I was saying earlier, if you really zoom in, you can see the right side. I mean, I'm in the United States, so I drive on the right side of the road. So drove up, came back on the same road, and then what I did was I went to the Loudon State Park, and there is this, as this shows, Black Hawk statue. So there's this big statue, which you can actually see in here. And I took a few images, and I wasn't very far away from the statue, but and these images I was taken in pretty close proximity to each other. But this was the first image I took, and the preview shows, and this was back in this direction. This application actually allows you, using this icon, it allows you to set the position in which you were shooting. So like in this case, I was shooting over in this direction. And then what that'll do for you, I'm right-clicking and now looking at the data. And what it does in this case is it shows the image direction, and it adds some additional information in the XF data for the image. But I'm not really interested in describing that or showing that. What I'm more interested in showing is that just that the position information is correct. In this particular shot, I was shooting toward the west. If we zoom out, we'll see that directly due west of me is the Rock River, and you can see the Rock River there in the other shore, the western shore of the Rock River. So that was positioned correctly, geotagged correctly. And then this image, I shot back in the direction of the statue, and you can see there's the statue again, and I shot this toward the north. So these are correct. And then what I did was, as you can see from this track information, is I went to this location and I shot back across the river at the statue. So I'm going to select this, and you can see that across the river, and there's the statue from a distance, and it's shot from here across. And so it looks like we've positioned geo positioned correctly. One of these images, the first image that we were talking about up here, this one is this image. As you can see, it has this additional icon that shows the position of the camera, the angle that the camera was shooting at, because I manually set that part. And so what we do now is, each of these images in GeoSetter, in this software, in this session, the position information is stored, but it's not stored in the XF information. As you can see, the XF information hasn't been changed because we haven't written anything yet. So I'm going to go back to GeoSetter, and now what we're going to do is we're going to save this. Now this takes a little while, and I timed it earlier, and it takes roughly 12 seconds per image. So what we're going to do is I'm going to pause the recording, and we're going to wait for these images to have their position information written to the XF information. So let's pause for a while, and I'll come back right before we're done. Okay, so we're back, and it is completed. It took about a minute and a half, minute and 21 seconds or so. And so we have now, you notice that the thumbnails no longer show magenta because no edits are pending writing to the files. So let's go back to AC/DC, and now we see that each of these images have this little push pin icon on them, and if we look at the XF information now, it has position information in it. And not only that, in AC/DC Photo Studio, one of the panes is a map pane, and so we can see that the images, they show up in yellow, are positioned correctly. So this particular one is one of the images that was taken near the power plant. Let me zoom out so we can see where this was. This image should be in yellow. There it is. I'm going to zoom in on this. And there's that power plant up and to the left. This is the image here. It's this image. The other image was at the end of the road. This particular one. So it looks like everything's correct here. Let's just do the map. It's a little bit easier to see things. It's not as distracting. This doesn't have the track information in it because AC/DC, this is just showing us information about the images. and it doesn't know anything about the track information. It doesn't know how we got this position information on there. In this thing, it shows if we're zoomed out, there's two images taken there, so I'm going to zoom in and then it separates them. So when you zoom in, it shows more detailed information. So that's about it. That shows how to store position information in files. And notice that it worked on raw images. If I now convert one of these raw images, in fact, let's do this just for kicks. I'm going to turn off the map pane. We don't really need to see that part of it anymore. I'm going to take this image and I'm going to convert this into I'm going to use the Dng Converter. So I'm going to take this image and I'm going to convert it from a Nikon NEF file to a digital negative, Adobe digital negative file, a DNG, and I'm going to put it directly back into the same folder. So save in the same location. It'll have it. This is what the file will look like. Let's just convert this. And this takes, it's pretty quick. It's already done. But the whole point of doing that is to show that even in a converted image, it still has the position information in it. I could then convert this to here. Let's do a batch convert. I'm gonna convert the file format of this, and I'm gonna make a JPEG image. I'm gonna place it in the same source directory. It's here. Let's do it. We'll start the conversion. Takes a couple seconds. We'll see another image will show up. It's finished. There it is, and we can see position information is maintained. So that's about it. That's all I wanted to cover.